Hi guys, so today we're going to be doing the rational zero theorem. What this theorem is going to do is it's going to help you more easily guess which numbers to test when finding the factors of a polynomial as well as their zeros and things like that. Okay, so as I said, the rational zero theorem can help you choose some possible zeros to test. Basically, it's dependent on the two coefficients. It's based off of your leading coefficient as well as your constant. Okay, so if this is your polynomial, okay, representing polynomial function with integral coefficients, if p over q is a rational number in simplest form and it is a zero of y equals f of x, then p is a factor of a sub 0 and q is a factor of a sub n. So basically what you're doing is you're finding factors of a sub 0 to be up here for p, and then the factors of your leading coefficient to be down here in the denominator for q. Okay, you'll see a little bit more about what we mean by that. Okay. And then, of course, then if that means our leading coefficient is 1, then really we just need to worry about factors of our constant, because whatever our constant divided by 1, it'll still be that. Okay, so let's start with example 1, where we're listing all of the possible rational zeros of each function. Okay, so here you need to look at two numbers. You need to look at your leading coefficient. In this case, it is 2. And you need to look at your constant, which in this case is 9. Okay? So then your possible rational zeros, you're going to list the factors of 9. Right? So that could be positive or negative 1, positive negative 3, and positive negative 9. Okay? So these are my factors of 9. Okay? These numbers come from that. Okay? Then on the bottom is going to be our factors of our leading coefficient. So what gives us 2? Positive negative 1 and positive negative 2. Okay. And then after that, we would probably just separate them. So obviously, if each of these are over 1, then we just have positive negative 1, positive negative 3, and positive negative 9, right? Because it's 1 divided by 1, 3 divided by 1, 9 divided by 1. Okay. And then we also have the ones over 2, so that will be positive negative 1 half, positive negative 3 halves, and positive negative 9 halves. And these are the possible rational zeros. So when we're using synthetic substitution, synthetic division to find our possible zeros, these are the ones that we're going to test rather than testing every possible number in the world. Okay? So then let's do 105 then. Okay? The leading coefficient for this is 1x cubed, so then it's just 1. Right? So I don't need to write the plus or minus 1 here, and 105. Okay. So let's list the factors of 105. Okay. So I have positive negative 1, it's not even, so no 2. 3, divisible by 4, this is divisible by 5. It's also divisible by 7. Divisible by 15, divisible by 21, divisible by 35, and divisible by 105. Okay. So one thing that happens is should pair up, right? Generally, unless it's a perfect square. 105 and 1, 3 times 35 gives me the 105, 5 times 21, and 7 times 15. So that kind of helps to check some of them. Okay. And then for 1, it's just positive negative 1. But since there really is no point in writing it if our leading coefficient is 1, now I have to rewrite the whole list. So plus or minus 7, plus or minus 15, plus or minus 21, plus or minus 35, and plus or minus 105. And these are the possible ones that I would test. All right. Okay, so why don't you try 1a and 1b to find all possible rational zeros of each of the functions, and then come check your answer when you're done. Okay, so for 1a, you should have gotten positive negative 1, positive negative 2, positive negative 5, positive negative 10, positive negative 1/3, positive negative 2/3, positive negative 5/3, and positive negative 10/3. Because on top is my factors of 10, and then the bottom is my factors of 3. Okay, and then they make my different fractions here. Okay. For 1b, you should have gotten positive 1, 2, 3, 4, 6, 8, 12, and 24. Top here is all my factors of 24. Bottom here is my factors of 1, which is really, there's no need to write it because it's the exact same list from the top. Okay, so here is the next example. Example 2. The volume of a rectangular solid is 675 cubic centimeters. The width is 4 centimeters less than the height, and the length is 6 centimeters more than the height. Find the dimensions of the solid. So I'm going to make my h height. Okay. Here it tells me the width is 4 centimeters less than the height, so that means my width is height minus 4. And the length is 6 centimeters more than the height, so length here is h plus 6. Okay. If this is a rectangular solid, the volume is length, width, height equals our volume. Okay. So here, let's make it all the same, same variable. So since all of them I can write in terms of h, we're going to write it in terms of h. So L is h plus 6. Width, we know 4 centimeters less, so h minus 4. And then h equals 675. Okay. So then we're going to find the dimensions of the solid. So we need to solve for h. So the first thing I'm going to do is I'm going to multiply. So this becomes h squared. Then here this becomes negative 4h. This here becomes 6h. And then this is negative 24. Okay. Then I'm going to combine like terms. So this is h squared plus 2h minus 24. Then now I'm going to distribute the h to each of this. This becomes h cubed plus 2h squared minus 24h equals 675. Okay. To solve this, I need it to be equal to 0, so I'm going to move the 675 over by subtracting it. Okay. Now I can find possible factors of 675. Okay. So let me list my possible ones here. So I have 1, 3, 5, 1, 3, 5, 9, 15, 25. I also have 27, 45, 75, 135, 225, and 675. Okay. So here I probably only have one positive ones, and we can't have negative height, so really I can take out all of the negative options. Okay, so I only need one positive real number. Okay. So let's test some of these, right? Some of them are starting to get a little big, so let's maybe not try that. Let me go get a scratch paper so that way I can test several of these. Okay, so let's test a couple. So let's start. So h cubed, so that's 1, 2h squared, negative 24h, negative 675. Okay? So the more you start testing, the better you will be at it. Okay, so let's just try 1, even though I think it'll be a little bit small. Okay, so here's my line. Okay. So 1 times 1 is 1, this is 3, 1 times 3 is 3, this is negative 21. Negative 21. Okay, clearly move on. Okay, so I think 1 is too small. Let's try 5. Maybe 5 might be closer. Okay, so obviously I know what the answer is in your book, but part of it you're just gonna have to keep testing some. Okay, so like 1 we clearly saw it was a little too far from that. Okay, so let's do 5.
Okay, so drop the 1 here. Times 5, 7, this is 35. Ooh, I think we might be getting a little bit closer. So 35, 24, this is 11, this is 55. So better, but still not there. Okay. So let's try maybe 9. So 1, 2, negative 24, negative 675. So let's test 9. 1 times 9 is 9. 2 times 9 is 11. 2 plus 9 is 11. 9 times 11 is 99. And then my 99 and negative 24 is 75. And then multiply by 9. And this gives me 675. So that perfectly works. So I have x squared plus 11x plus 75. So one of them, my height now I know is 9. Okay. So there you go. Height is 9. So find the dimensions of the solid. The height is going to be 9 centimeters. Okay. So then the width is 9 minus 4. So the width would be 5 centimeters. And then my length is my height plus 6. So 9 plus 6 is 15. So 15 centimeters. And you can check. When I multiply these three numbers together, do I get 675? Yes, I do. So there we go. And so the next one you could have done is figured out what this is, but here you'll see that you'll get 2 imaginary numbers because we're only supposed to have 1 positive because the change only happens once, right? And there you go. Okay. Okay, so why don't you try CYP2, and then once you're done, come check your answer. Okay, you should have gotten a width of 11 inches, length of 12 inches, and a height of 8 inches. If you got that, you can move on to the last example. If not, here is your explanation. Okay? So here, everything is in terms of the width, so W is width. Length is 1 inch more than the width, so that's why L is W plus 1. Height here is 3 inches less than the width, so that's why it's W minus 3. And I know that my volume is 1,056 cubic inches. Right, so volume for a rectangular solid is length times width times height, so that's why length times width times height equals my volume. Then I FOILed or distributed, multiplied the W plus 1 and W minus 3, and I got this, W squared minus 3W plus 1W minus 3. And I just moved this W towards the end. Then I simplified by combining like terms. The negative 3W and W is negative 2W. Then I distributed the W to everything here in the parentheses. That's why it becomes W cubed minus 2W squared minus 3W equals 1,056. And then in order to solve this, I need to move it all to the same side. So I subtracted the 1,056 on both sides. Okay. Then I wrote all of the possible rational zeros. I didn't do the negatives because length, height, width can't be negative. So that's why I only wrote the positive ones. So these are all of the factors of 1,056. Okay. After that, I started just picking which ones I thought would help. And so since this was 675 and my height was 9, if this is 1,056, I thought it definitely had to be greater than 9. So to not be too ambitious, I just tried 11. And it worked. So I tried 11 here. So I did 1 W cubed minus 2W squared minus 3W minus 1,056. So I tested the 11 and it worked. So 11 times 1 is 11. Negative 2 plus 11 is 9. 11 times 9 is 99. Negative 3 plus 99 is 96. And 11 times 96 is 1,056. And with this negative 1,056, it's a remainder of 0. So it is a factor. So my width is 11 inches. My length is 1 more than that, so that's why it's 12 inches. And my height is the width minus 3. So 11 minus 3 is 8 inches. And that's how I found my answer. Okay, so now we're going to use that, and we're going to find all of the zeros now. So we're going to use all of that and put it together, and not only find the rational ones, but any of the irrational ones or even the imaginary ones. Okay. So here it says to find all of the zeros of f of x equals 2x to the fourth minus 13x cubed plus 23x squared minus 52x plus 60. So first of all, for positive zeros, I already know I'll have 1, 2, 3, 4. So either 4, 2, or 0, positive zeros. Okay. Negative zeros, if I put f of negative x, this will still be 2x to the fourth. This will now be 13x cubed. This will be 23x squared. This will be 52x, and this will be 60. So what this tells me is that I have 0 negative zeros. So 0. Okay? Which that means if I have my imaginary ones, that means I either have 0 imaginary, 2 imaginary, or 4 imaginary. But if we have 4 imaginary, then we're kind of hopeless at this point. Okay, so let's find some. Okay, so all of my possible rational zeros. Right, so possible ones are factors of 60. 1, 2, 3, 4, 5, 6, and then I have my 10. Okay, then I'll have 12, 15, 20, 30, and 60. So those are the factors of 60 all over the factors of 2, which is 1 and 2. Okay. So we don't have to worry about any of the negative ones because there aren't any. And so let's get started. Okay, so if we compare, 60 is smaller than 675, I feel like, but this is pretty big. So probably somewhere around here, I would say. So let's try a couple. So let's try 4. So do 2, negative 13, 23, negative 52, and 60. Let's test 4. Okay. Obviously in the book I know what the answers are. I could have just tested those, but just so that way we get some practice and start seeing how these numbers work so that we can test better. So 4 times 2 is 8. Negative 13 plus 8 is negative 5. 4 times negative 5 is negative 20. This is 3. This becomes 12. This is negative 40. And then this becomes negative 160, which is negative 100. So that doesn't quite work. So we want this to be a little bit smaller. So why don't we try 5? Let's do the same thing. 2, negative 13, 23, negative 52, 60. Okay. Drop in the 2. 5 times 2 is 10, negative 13, negative 3. This is negative 15. This is 8. 5 is 40. This becomes negative 12. This is negative 60. And this is 0. Okay? Nice. So this one works. So 4 didn't work, so cross out. Okay. So now I can test using these ones as well. Okay. So here now I have 2x cubed, right? Because it was x to the fourth, so now it's 2x cubed minus 3x squared plus 8x minus 12. Okay. And then, if it's factorable, then we're going to factor. If not, then it's not, right? Okay, so then 2 to the x squared. I think it's factorable by grouping, so let's factor by grouping. So I'm going to split this into 2 groups. Looking at my first half, x squared is a factor, and then I'm left with 2x minus 3. Here, 8x and negative 12, 4 is a GCF, and then I'm left with 2x minus 3. So now I have x squared plus 4 and 2x minus 3. Okay. So then set each of these factors equals to 0, equal to 0. Okay. This is 2x equals 3, and then x equals 3 halves, so that's one of them. Here, subtract 4 on both sides. Square root both sides, so plus or minus square root of negative 4. That negative is going to come out as an I, and square root of 4 is 2, so 2i. And so the zeros are 5, which worked when I did synthetic substitution. Okay, 3 halves. And you'll see that that's one of my possible rational zeros, right? 3 halves. Okay. And then we have 2i and its complex conjugate, negative 2i. So these are all of the possible rational zeros.
Okay, so why don't you try CYP3B, and then once you're done, come check your answer. Okay, so for your zeros, you should have gotten 2, 1/2, 3i, and negative 3i. If you got that, you can get started on the homework. If not, here's your explanation. So just to kind of help me figure out what kind of numbers I want to look for, so using Descartes' rule of signs, I figured that there's 4 sign changes. So I either have 4 positive zeros, 2 positive zeros, or none. And then when I did h of negative x, there was no sign change, so that's why there's 0 negative ones. So I don't have to test any negative numbers. There's not going to be one. Okay. And then the imaginary, there's either going to be 0 if they're all positive ones, 2, or 4. Okay. Then I set up which ones I did the rule, the rational zero theorem, right? So then all the factors of 18, 1, 2, 3, 6, 9, and 18. Factors of 2 is 1 and 2. Then I started testing things, right? So I definitely knew it probably wasn't going to be on this side. It would be too big. So I just was like, maybe 2. So I tested 2 out and it worked. Right, so drop the 2. 2 times 2 is 4. Negative 5 plus 4 is negative 1. This becomes negative 2. This is 18. This is 36. Negative 9. Negative 18 and 0. If you tested 1/2, it would have also worked, right? That's why it ends up being one of my rational zeros. You see that here, 1/2. Okay. But after I got the 2, using the depressed polynomial 2x cubed minus x squared plus 18x minus 9, right? Because now instead of x to the 4th, it's x third. I realized that I could factor by grouping, and so that's what I did here. For the first half, x squared is in common, so I'm left with 2x minus 1. Here, 9 is in common, left with 2x minus 1. So since these match, I knew I did it correctly, or that at least it's factorable by grouping in this case. X squared plus 9 is one factor, 2x minus 1 is the other one. Set each equal to 0. Okay. Subtract 9, square root both sides. The negative comes out as an I, and square root of 9 is 3. So that's why I have 3i and negative 3i. And then 2x minus 1 equals 0. Add 1 divided by 2, so x equals 1/2. And there you go. That's it for today. Have a great rest of the day. Bye, guys.